start with the just like introduction from the data science. I start with this one. This is the fast. So just sync with my speed, and we can go ahead with the other things also. So this is the fast track agenda for that. Why the need of data science? What is the life cycle of the data science? Applications of the data science. Introduction to R and introduction to R Studio. So as this session is for just like by using R, so definitely R is playing. R is a language, and this is the basic difference where R is a language for the different kind of the statistical analysis, and top of that you are using R Studio. So R Studio is an integrated development environment for that one. And if you are doing the practice kind of thing, then definitely you have to install R in your machine also, and the top of the level you have to install the IDE for that one, that is the R Studio, so you can work for the different practice session for the data science also, and you can do the analytics and other things also, then making a different kind of models and predicting them, and then finally you are getting the result kind of thing. Need of data science, as you know that there is just like I'm giving a simple example like that, just like share traded on US stock market, each day it is generating more than 10 billion kind of the data also, and the data generated just like the one flight from the New York to London, if it is going, it is just like 10 terabyte data generating. Number of the tweets per day, if you are seeing on the Twitter, it is more than 500 millions, and the number of the likes are in the Facebook like that, it is more than 5 billions, like that kind of the stuff. So there is a huge data, and previously the data is like that is a kind of single type of the data like that. You are getting stuff 10 years back, there is a scenario change in last 10 years you can say, and you have a mixed merge kind of the data, and data will be in the variety. It is in the form of the picture, it is the form of the videos, it is form of the like that JSON kind of the format, XML kind of the format. So lot of formats are from the API, it is generating the data. So huge data you are getting from the different sources, like PDF file you are having, like generally you are having a different kind of the files structure, might be Excel, might be a different kind of the various data also, data sources also, SQL server, Oracle, like that, no SQL DB, MongoDB, like that kind of the stuff. You are getting a mixed merge kind of the data and finding out the things from your data you want to do the analytics. So this is the case of that, why the data science is needed. And what is data science? Basically you are incorporated the science into the data, then it becomes a data science you can say. So this is the case basically, and definitely you can go for the life cycle of the data. So you have just taking the data from the very source, accumulated them, and you are making a data warehouse from that one, and after that you are filtering those data, and then after that you are making some kind of the model from that data, and then you are visualizing the data and finding out the result for the industry or for the customer, for those you want to do the predictions or the data science analytics you want to do. So that is the case. Definitely applications of the data science, we can go ahead. Lot of applications are in the data science like that. In the banking there are so many cases, just like you want to find out that whether this loan is right or wrong, like that this person will be just like repaying is right or wrong. On the basis of the previous data you can see the analytics, or you are doing the analytics, and you can find a lot of things from that. That is a small example. There will be another example in the life insurance domain, might be in e-commerce industry. They are searching the, just like on the basis of your real-time purchasing or real-time watching, what the things you are watching, on the basis of that they are just like doing and giving you the combination of that, you can buy this product on the combination of that product, like that kind of the stuff they are doing. Netflix is also just like you are watching the movie, and according to that it is showing you that this recommended movie are there for that Netflix. So there are a lot of opportunities, just like the telecom industry is finding the churning, and that how the people are churning from their company, what is the reason behind that from the parameter. So we can take the real scenario on the basis of that telecom industry also, and I can show you the things also in the, that is the case. So this is the fast track for this one. So you have a just basic background. I understand that, I hope so that you might be a basic understanding of the data science. So we are not going in the detail for that one, because the topic is decision tree and random forest. So we can have a, we can to understand the these things. So decision tree and the random forest is comes under the supervised learning. So you know that supervised learning is just like I am giving you the training, is a kind of example of the supervised learning, and if you are learning yourself is an example of unsupervised learning. And there is a reinforced learning on the basis of the different experiment, or the on the basis of the previous data, you just like you are doing some certain kind of the thing, that is a reinforced kind of the learning, like that automated car without the driver, it is just like running. It is a kind of example of the reinforced learning, you can say. Very simple example I'm giving. So that is the case. Now this is the main agenda which we want to discuss. Number one, understanding the classification. Number two is the decision tree. Number three is the demo on decision tree. We can go for the demo, just like how to create a tree model, bagging, random forest, and the demo for the random forest model also. So time permits, basically it is a 1 hour webinar, so I have to cover most of the things whatever is the needed. But actually if you are doing the complete course for the data science, definitely you will learn in the depth. Only the thing is that you have to understand this concept, that what do you mean by the decision tree and what do you mean by the random forest. That is the case. In 1 hour duration, definitely you can understand a lot of things, no doubt. But definitely when we go in the detail, you have to learn a lot of things in that also, because it's a practically hands-on approach we can go. Definitely we will do some practical also in this session, so it will be much more clear to you as a conceptually. So let's understand that what do you mean by the classification. So classification, basically it is a process for grouping the things according to a features or the similar feature kind of the things, like that. The example is given in this. I am taking one example, that there will be arrangement for the different papers. So if you are having a different newspapers and you are just are the kind of the paper you are putting on that bin, and there is a metal you are putting on the other bin, and there is the plastic you are putting on somewhere else, e-waste is putting on somewhere else, glass is putting somewhere else, and organic kind of the stuff you are putting in some. So you are just like separating by the groups. So that is the case of the classification. I hope so that you know the data type. Basically these are the two types. One is the continuous data, and another is just like that is known as the linear regression. You have to do it. So because you are learning this decision tree, so you know that what do you mean by the linear regression, logistic regression, and what is this tree or the random forest you are doing. So in linear regression, when the continuous type of the data is there, then you have to use the linear regression kind of the model, and you have to prepare that linear regression model, and after that you can just like do the analytics and the prediction kind of things. In logistic regression, where is the categorical kind of the data. Categorical means just like it is a category, you are just like dividing into the position, just like it is a kind of 0 or 1 or yes or no or true or false. That kind of the stuff you are having, and you are finding you want to do the analytics. On the basis of that, you can create a tree model, and from that tree model you can just like do that kind of the stuff. So that you can do in the logistic also, logistic regression also. But the top of the level, if we are going for this tree model and the random forest model, the advantage of this one, you can use the linear as well as the categorical kind of the things also. But that you have to convert, that there is a process. So you have to convert your whatever the linear continuous data you are having, that data you have to convert into the just like yes no kind of thing, or the true false kind of the thing, and after that you are generating a model. That's the case. Like that you can just understand by this simple presentation that what is the difference between the classification and the regression. So when you are getting a data, according to that you are just like, if you are plotting the graph on the base of, just like it is a graph for real returns and the return predictions, that kind of the things. So you are seeing that there will be some straight line you are finding here, that is just like the data is just like above and below is also there, but there is a straight line. So this kind of the example is for the linear regression kind of the things. And just like the data which is above the line or the below the line is known as the residuals, that is a kind of error you can say. And but it is a good model, so you can predict the result on the basis of this linear regression model, and you can find out the accuracy, and then you can have a prediction kind of the thing. So this is the continuous data, and you are having a continuous value according to that, and you are making certain kind of the model. Where in the classification you are having a just like two types of the whether it is true or whether it is false. Just like it is example, it is a bull or it is a bear. So that is a categorical variable values you can say, whether it is a yes or whether it is a no, that kind of, whether it is a true or whether it is a false. So that is the stuff where you are getting the things according to. Then you have to understand that what you mean by just, this is the main object of this today's session, that you have to understand decision tree model and the random forest model, so that you know that there is a tree structure. It is very simple to understand what you mean by the tree structure. So you have a you can create a tree structure according to that one, and then you can find out the things from that. So there will be just like first you understand what do you mean by the decision tree, and what do you mean by the, then we go for the random forest second step. So first we try to understand that in the classification model there will be a three kind of the main, which is I'm taking as a consideration. There will be might be more type of the classifications also. Right now I'm not considering because it is just like we have a 1 hour time with us. That is the case. So we are taking just to understand that what do you mean by logistic regression, what do you mean by decision tree, what do you mean by random forest. So very first is the logistic regression. So logistic regression is used when the dependent variable is a categorical, and I hope so that you understand what do you mean by the categorical kind of the variable, whether the variable is yes or no, whether the variable is true or false, or whether the variable is like that, you can say it is a 0 or 1, or you can say it is a kind of binary also. And that will be a case of logistic regression. Just like example is given here, if you want to find out that whether my email which is coming is a spam or not, so like that for the spam it is just like yes or in. Yeah, that we will do. Just go, just first you try to understand the things, and then definitely we can go ahead with this. So there will be a, to understand, that is a decision tree, that is a graphical representation of all the possible solutions to a decision. So just like it is a very simple example it is giving, that is a person fit. So this is the questions, and now you are creating on the basis of the age, you are creating a tree structure. So like that in this scenario we are assuming that if age is less than 30, then there will be a, just you are finding out from your data, those are having less than 30, it is going to the true or it is yes, and those are having a not less than 30, it is going to the no, that kind of the stuff. And then after that there will be another questions you are asking, that eats a lot of pizza, for example. So if you are getting just yeah, it is the person who is eating a lot of pizza, are just like we are just like treating them and saying them those are unfit, and those are not eating a lot of pizza, then they are the fit. That is the case. And here also when the age is less than 30, it is no. So in that case you are asking the question that exercise in the morning. So if it is yes, then they are fit, and if it is just like a kind of no, so it is unfit. So finally you are getting the till the data, you are getting a result, just like you want to find out the fit and unfit from that one. So this is a categorical kind of the data where you want to have a structure kind, this tree structure. So this top node is known as basically the root node of your tree, and this process is just like when you are splitting the things on the basis of yes or no, or on the basis of true or false, or on the basis of some condition, is known as, the process is known as splitting. And if you are just like taking this as a two nodes, this is one node for each for this one and other is this one, so these all also known as the child node as far as this is a parent node is concerned. Like that in the last, if we are saying that these two are the child node, so the parent node is the top of where the my cursor is, that is known as the parent node also. So these are the terminology related to the tree view. Just I am explaining what is the process for to understand this decision tree. We can go ahead with the other example also, so it will be more clear to you. So this is just like, so decision are, you can say, mainly based on some conditions. So definitely you have a condition like that eats a lot of pizza, so this is the condition, you are asking some question, and on the basis of that you are getting yes or no, and you are finding out that whether he is unfit or whether he's fit. Like that in the exercise in the morning you are getting the answer yes or no, and on the basis of that, if it is yes, then it is fit, if it is no, then it is unfit. So these are the based on the conditions you are getting the decision. So decision made can be easily explained. So for as far as understanding is concerned, tree model is very easy to understand. So that is the best advantage of this one, and it will work for the both the case. Basically I already tell you, so this is the basic advantage. Just like you understand, the third one thing is that is a random forest. So random forest build the multiple decision trees and the merge them together to get a more accurate and stable prediction. The meaning of that, just you are splitting the tree from the different, just like tree 1, tree 2, tree 3, tree 4, tree 5, tree 6, might be up to 20 tree, might be up to 100 tree, might be up to 50 tree. That is depends on your data size. And from that you are having a class C, class D, class B, like that kind of the thing, majority voting you are taking, and from that you are just like having a final answer for that one. So correct decision trees have it of overfitting their training set, and that train will be the bagging method. So I can just give you the example, what do you mean by the overfitting also, what do you mean by the bagging also, that is the case you can do. So just like this is the slide I'm taking just for just getting this. There are a lot of algorithm available for as far as the model is concerned in our language, and you can find out. You can search in the Google also. There are a lot of examples are given for that those also, and there will be so many books are also available. Like that, already there is a library of more than 10,000 packages which is inbuilt library in R, and you can use those packages and you can just like do the task, different tasks. So these are the common things which are the common algorithm. We are just like you understand that what is the terminology. I'm not going into the detail because we have to be a practical approach, and you can understand that what is called classification and regression tree. Like that case, we have taken one example. So there is the algorithm ID3, there is the C4.5, C5.0, CRT, that is the classification and regression tree, and there is a CHAID, that is a chi-squared automatic interaction detector. So that is the case. So that you have to understand. These are the just like terminology or naming culture, you can say, for the algorithm, and these are having inside of this. There will be a kind of different kind of the functions. On the back end, it is written by the programmers, and that you are utilizing in your R Studio, and from that you are creating certain kind of the model, and you are getting a result on the basis of that. And then you have to find out the accuracy level of your model also. Then you have to understand, just like it is a part that you have to understand the decision tree. What do you mean by the decision tree, and what are the different terminology related to the decision tree, that you have to be understand. So just like it is a root node, that is the represent entire the population, or you can say sample, and that is the topmost node of your tree, and it is known as the root node. So this is the case. Another thing, that is the leaf node. Leaf node is just like a bottom node. On after that there will be no separation, like that in the example previously I have given, the last node is also known as the leaf node. That is the case. There is a process splitting also, that is divide the root node or sub node into a different part. So this process is known as splitting, like that. From the top of the level, if there is a yes, then it is going to the left side, right, no, then going to the right side, like that. It is an example. So this process is just like known as splitting. So you are splitting your from the top of the label, you are splitting to the two, then again you have some kind of the question, and you are again splitting that into the two ways. So that process is known as splitting. There is another process, that is another terminology, that is a branch or subtree. So from the each node, you just like when you are divided into the two, and if you are just like splitting from that one, so that is known as the branch or subtree also, you can say. I can give you the example also, so that will be much more clear to you. These are the just terminology. And pruning, just like on the opposite, it is the opposite of splitting also. And you can say when the basically you are removing the unwanted branch from the tree, and you are just like separating that branch from your main tree. So that process is known as pruning, and on the basis of that one, you are finding out certain kind of the result also. And there will be a parent and child node, that I already explained while taking. A topmost node is also root node, is a, suppose that is a parent node. When you are splitting that thing in the two nodes, so that two nodes are the child node for that parent. And even that child node might be converted to the parent node, because if child node is also divided into the two parts, at that time that child node is known as parent node, and then downside the two nodes are known as the child node for that case. So this is the example to understand that how you are visualizing the decision tree. It will be much more clear to you. So I'm taking a very simple example, taking only 4 data, in which I am having a color and the three variables. You can say there is a color, there is a dimension, and there is a label. So in this example, just see, there is a color green, in which diameter is 4. There is for just you understand that it might be a 4 inch, you can say, as a diameter. So it is a unit for that one. And then if their color is green and diameter is this 4, the label is we are putting as a mango. There is a color is yellow and diameter is also 4, then we are putting the label as lemon also. And then there is a there is a red color, then dimension is say 2, then we are giving label as a cherry. And then there is a color yellow and diameter is 4, then we are giving this also as a mango. So just see here, in this example I'm just like covering the things also conceptually. So in green label also there is a diameter 4, and that is also mango. And then there is a yellow label also, there is a diameter 4 also, and that is mango also. Might be possible in yellow case, yellow 4 inch also, that is a lemon also, and then there is a yellow 4 for mango also. So this is very simple example to understand. So while I'm making the visualization of the tree, just like I'm making this as a question, I'm asking that is diameter is 4 greater than equal to 4, for example. If might be, this might be false or this might be true. So if it is greater than equal to 4, it is a false, then definitely you are getting that that might be a 100%, you can say it is a diameter 2 is there as far as data is concerned. So you are getting just like it is a cherry kind of thing. Here also, if you are just like going to the right hand side, then it is a true, greater than or is equal to 2, so it is 4. So you are getting an 4, green, yellow and yellow. These are the like that mango as well as the lemon and then a mango. So this green is 4 mango, yellow is 4 mango and yellow is 4 mango. So you are, it is true. So you are getting this kind of the data. After that, you are asking for the second parameter, that you have to ask for the color basis, on the basis of color. So on the basis of color, you are finding that is color is equal to yellow, just like it is a question for this. So if it is a false, so definitely it is a green in that case, because it is not a yellow. So in that case, you are getting 100% as a mango as a result. But when it is a true, in that case, because there are a 4 mango and the 4 lemon all there in the like that yellow color also. So you are getting just like out of that, if you are just predicting, so the probability is 50% mango is there and 50% lemon is there. So this is just like to understand that how we are visualizing the small data in a kind of the tree structure. So it will be just like easily understand to all of you. Let's take the other example also. So the in this scenario, the reason just like as we are seeing the data and we are just like putting the data here and we are finding out the just like creating a tree kind of the structure. The most important thing is that what is your root node. Here I'm taking diameter, why I'm not taking color here? That is the question. So the thing is that on the what basis or on the what parameter basis you want to split your tree. So this is a known as just like you are doing the analytics on that one, and you are doing just like using data science in this one, because this is very small data. So just like you are seeing manually and you are doing the task. But when the data is very 10 billion rows, 100 billion rows, in that case you want to predict a model, you want to generate a model, you want to build a tree model, then it is difficult. And there are a lot of parameters like that. Here only 3 parameters, might be possible there will be a 5 parameters, might be a 7 parameters. On the basis of that you want to predict something. In that case, it is very necessary that how you are just like creating this kind of the decision tree, and which is the best part to take the just like the top of the node on that basis. So for that, there is a terminology. You have to find out the Gini index. So Gini index, just like the answer, I can explain that whenever the Gini index, if you are finding out and you want to take the average, weighted average for that one, from that Gini index, you can immediately tell that what the highest point you are getting, just like the highest number you are getting for the Gini index. On the basis of that variable, you have to split your tree. So this is just for the understanding purpose. So I'm giving you a very simple example, so it will be much more clear to you. So we have a sample of 30 students with 3 variables. One is gender, that is a boys or girls. Another is a class, that is a 9th or 10th class, and there will be a height. That height will be might be from 5 to 6 feet. So that is a kind of example, like somebody is having 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, like that till 5.10, 11, and then finally 6 feet. So these are the case where you are having a height. So in that case, you just like taking just like as a say mid levels, whatever the 5.5 height is there, greater than of that one will be going playing the available for the cricket, and for less than that they are not playing the cricket. It might be that kind of rest, or you are splitting your height in the basis of some mid parameter, you can say. So that is, you can say, threshold value, you can say. So there is a new terminology coming, that is a threshold value. So I can explain you that what do you mean by threshold value. So it is just like I'm taking another example like that. You have a CPGA of the different student, just like from the class 12 onwards, and then they want to take the admission in the university or in the institutions like IITs or any other big institutions, Harvard or MIT, like that kind of stuff. And university is saying that what the CGPA, if it is greater than 8, then you will get the admission, otherwise not. So you have a say 1000 student data, in which somebody is having 5, somebody is having 6, somebody is having 7, somebody is 8, somebody is having 8.25, 8.9, 8.9, 9.1, 9.8, 9.9, like somebody is having 10 might be possible. So this is the case where you are having 1,000 data with you, and then university is saying that the greater than equal to 8 we can give the admission to the students, that guys. So this is like threshold value for the university is greater than equal to 8 in that case, because greater than equal to 8 is the yes condition, and less than that is the no condition, like that kind of the stuff. So this is the threshold value for the university. So generally when we are splitting the data on the basis of just like assuming the data might be possible that you have a might be a different threshold value for your data, and after that you are just like assuming that I can consider my threshold value like that 70-30 or 65-35 or 75-25, like that kind of the stuff you can take it as for while you are spreading your data and all these things. So that we will go in the later stage. First we want to understand that how we are building our tree on the what basis. So this is the case like that here we are just like immediately in decision tree we are taking the example, and we are just like taking that on the basis of the diameter we are splitting, and after that we are basing on the color we are splitting the tree. So how this diameter is taking as a top of the level, why not color is there? So that is the question. So for that we are calculating the Gini index. Just you understand by this very simple example, and you can learn that how we are calculating the Gini index. On the basis of Gini we are creating our tree structure. So right now you have a 30 student with the variable is 1, and then you have a 15 out of these 30 plays cricket in a leisure time. Now I want to create a model to predict who will play cricket during the leisure period. We need to segregate the students who play cricket in the leisure time based on the highly significant input variable among all these three. So this is the example is taken by the three variable. One is gender, another is class, another is height. So this gender is on the basis of boy girl, and class is 9 10. So definitely in 9th also boys is there, girls is there. In 10th also boys and girls are there, and definitely this height is also available in 9th also, in 10th also this height is available. So this is the mixed merge kind of the data. Like that the real scenario when we go to the inside of the data of it, I'm not showing you the data table, but I'm giving just like the example, just assuming that on the basis of spreading the gender there will be 15 are the playing the cricket. So there are the just like it is a 50% it is coming that 50% are playing the cricket, and there will be a female student out of which 30 students there will be a total 10 female and 20 males are there. So that is the case to understand that how many males and how many females. So just let's do the exercise that how we are finding out the Gini index for this one. So I'm taking you as a just like as a practical approach. Just we can have a Excel just open. If you are having Excel, you open that Excel. Also you can do the practice on that also, so that you can find out that how we are creating that kind of the things basically, and Gini index as a practical. But basically this is for your basic understanding that why we are considering this Gini for creating a tree model. But out of the base you can say when you are creating a model in R language, the different packages and functions are already ready to use. There you don't need to create a Gini index like that. Just what we are doing in the manual basis. But maths behind it, that you have to know it. So you know that what is the meaning of it. Just like we are creating, just like here have a total student is equal to, for example, in that example we have taken already 30, and we take the different kind of the variables also. So I can put here variable. So these are my variable. First variable is my gender. Another variable I'm taking as a height. Then another third variable I'm taking as a class. So these are my three variables. So this is 1, this is 2, and this is 3. So the same way you can do it. And here we can just like put that in gender we have a two types, like that one is female and another is the male. So I can write here female and male. In height, so I can just have a 5 to 6 feet. So I consider my threshold value is 5.5. So I can just like take 5.5 is less than 5.5, how many guys are there, and greater than 5.5, how many guys are there. Greater than or equal to, you can say greater than equal to 5.5 feet. So this I'm taking as a threshold value, and according to that I'm just putting the data here. So this is my actual data, which is I'm writing here. So total students is 30, out of which female are 10 and then male are 20. So just like see in the example I'm taking, just like female is 10 and the male are 20, and on the basis of height there is a 5 point less than 5 point in which male and female are there are 12 students, and greater than 5.5 here there are 18 students. So we are considering assuming the same data, so I'm putting here 12 and the 18 data here. And then in the class basis, so there are the two class, one is 9th class and another is 10th class. So I'm taking these two classes. So in 9th class, there are a 14 student, and in class 10, there are a 16 student. So I am putting this as a data, that is a 14 and there is a 16. So in last, I can just like sum up. So you are getting a complete strength of that one, and definitely it is taken from the real data. So this you are getting sum as actual, that is the 30 you are getting final as a final figure. So if I'm summing this one, just like it is 30, it is also 30, it is also 30. So this is the case where you are just like summing it and you are getting the total data. So this is your data 1, data 2, data 3. Now then these are the strength. And then how many playing the cricket. So you have a next data, how many students are playing crickets. So just see this example which I have taken in a presentation. In this, from 10, two people are means two female are playing the cricket, and from 20 there will be a 13. So I can put 2 and 13 in my Excel here. So these are the 2 and this is 13, and I can take the sum of this also. So will be just like I'm getting 15. So definitely from total student 30, and total playing strength is and playing cricket 15. So I can write here playing cricket is equal to 15. So this is my base data, so top of the level, and this is my different data. So I can just have a just like this is one case, so I can put in this is the another case, second case. So just I can have it, and I can insert this one. So this is my third one. So these are the three things which I am having as a data. So just like check that for height which is having less than, say for example, it is less than 5.5, you are having out of 12 playing cricket is 5, and out of greater than or equal to 5 out of 18 you are having 10. So I can put 5 and 10 in this Excel also. So this is the data I'm getting here, 5 and 10. Definitely if I'm doing the sum of this one, you are getting as a 15 here also. So this is, and the third one is on the basis of class also. So in this 14 out of 6 they are playing the cricket, and in case of class of 10 there is a 16 and 9 are playing the cricket. So we can take 6 and 9 in this case. So we are taking the data 6 and 9 here, and just like go ahead with this the total. So you are getting a sum. Now you have to calculate the probability of that one. So how you are getting the probability? So I can find out the probability. This is the probability of success, and this is the probability of the failure. So this I denote by with Q. Okay. So the probability of the success is what? It is total, just like number of playing. This is how many number of the playing the cricket and from the strength. So it is just like this divided by this directly you can do. So this is the probability of success. So I am getting this is 2 divided by 10 here. So this is my cell is G6. So I can write here plus G6 divided by F6. So I'm getting a direct probability from here. So 0.2 is the probability for this one, and I can have it just like if I'm copying this one, so I'm getting the other probability also. Not necessarily you are getting probability for the total also. The same formula, if I'm copying into the other cell, I'm getting the probability of those also. Similarly, you can copy this formula to here also, so you are getting a probability on this also. So just you can do on your Excel also, and just you can just like format this cell on the basis of number where decimal place are the 2, so it will be much more clear to you that you have a 0.20, or you can say it is a 20%. 0.65 means it is a 65%. 0.4 is a 42%. 0.56 is a it is a 56%. It is a 56%. What is the probability of failure? How case? Tell me. So it is just like you can just like 1 minus this probability of success, you are getting the result as a q. So you can just like plus 1 and minus, there is a cell I6, so I can give I6 here, and I am having a probability of failure. When you are having a success probability 20%, the meaning of that 80% is the failure probability. Here is 65, meaning that is 35. So you are getting directly, if you are minus 1, then you can have a direct probability there. And you if you are knowing how the probability is calculating, then you can calculate in yourself also. But it is just like simple formula I'm using, and you are having just like getting the answer perfectly. And just like the probability of success, if you are just like when it is a 20%, definitely you can say the probability of failure is 80%. Sometimes just like I'm giving you another example, there is a head and tail on your coin, and I'm asking that what is the probability of getting head, or what is the probability of getting tail. So just like you are saying that there is a two things, and if there is a 100% probability, if I divide it by 2, so there is a 50% probability of getting tail also, and 50% probability of getting head also. That is the case. So you can find out the probability on the basis of that one. So this is the probability you are getting, and from that you have to find out the Gini index. So Gini index is nothing, it is a probability of the success whole square. It means the P of whole square plus Q of whole square. So you have to be a this is the just like you can say it is a formula for the finding out the Gini index, and it is not a weighted in Gini index. Just like you are finding out the probability of the success whole square plus probability of the failure whole square. So you have a two value here. So just like you can just do this whole square and this whole square. So this is my I6 and this is my J6. So what I am taking is plus I6 the power of 2 and plus J6, and then I'm giving the power of 2. So I'm getting the probability is 0.68. That is my Gini. So just you can just like copy this formula and just go ahead with this one. I'm a little bit fast right now. Reason is that we have a time limitation and we have to do a lot of things. So just like I'm doing a little bit fast, don't worry about it. When you join the actual class, it will be I'm syncing with your speed. So I can reduce to just like to 10% also, 20% also, 50%. It depends basically how you are syncing. It depends on your experience and the expertise level. That is the case. So this is the Gini index you are getting. Just like see here, you are getting here 0.68, 0.55, and here 0.51, and here also 0.5151. So this is right now, it is not a weighted average. If you want to take the weighted average, then definitely you have to put like that, this kind of the formula out of the 2 divided by 15 multiplied by 0.68 plus 13 multiplied by 15 divided multiplied by 0.55. After that you are getting a weighted average. So that is the last thing. But by seeing this one, you can immediately say that the highest is the gender you are getting as a p square plus q square. So the tree will be split on the basis of gender first. So this is the case. This is just I am explaining you Excel. I am just like not going to the other, taking the other formula, because we have to create a tree model also. So that will be better in the sense. Like this way, in this example, I already tell you that this is the kind of that where you are playing this one and you are just like finding out the average. This is 0.68, 0.55, and 0.59. So highest you are getting on the basis of gender, you are getting 0.59 as a weighted average. 0.68 here and 0.55 here. This is we have done in exercise. Just see here 0.68 and 0.55. This is the same figure which we are getting in this one. So I am just explaining you the thing on the Excel, so it is easy to you. That is the case. And finally you are finding out the weighted average. That will be the 10 divided by 30 multiplied by 0.68 plus 20 divided by 30 multiplied by 0.55, and you are getting 0.59 as a weighted average. The similar way you are calculating the task on the basis of the class also, you are getting 0.51, and the similar way you are getting a third task that is on the basis of height also, then you are getting also 0.51. So the answer is that on the basis of gender you are splitting your tree. This is the case. Now next is you have to understand the confusion matrix also. So the reason is that confusion matrix, to understand this one while you are creating a model, so you know that how to split the tree and all these things, and you are creating a tree model, and after that you are building your model, and after building a model you are predict something. So after prediction, it is requirement is that you have to create a confusion matrix on that one, and from confusion matrix you can just like say that you can find out that what is the basically accuracy level of my model that you can find out. So this I am explaining you. Before that, definitely I want to tell you that we want to create a model in tree. We have to create a tree model also. So definitely just you understand this also. So before understanding this confusion, first you understand confusion matrix, then we can create in 5 minutes, we can create a tree model. So I'm explaining you that what do you mean by what is confusion matrix, how to calculate confusion matrix, and interpreting confusion matrix also, and creating the confusion matrix in R also. So backend mathematics, we are not going inside it. Only the thing is that interpretation is very, very important, that how you are interpreting your confusion matrix. That is the case. Like that, I'm taking a very simple example here. The confusion matrix shows you the ways which you classification model is confused when it make it predictions. That is the case. So when you are creating your model from the true value, suppose you are creating on the basis of churning of your how many people are churning from your company, and you are having churning yes or no. So you have a actual data also, and that is the churning data, and you want to take the prediction data also by creating the model, and that you are applying to your test model. So in that you have to create a train model also. After training the model, you create the test data set, train data also, test data also, and after test data you are creating that kind of the confusion matrix also, means you are predicting the model, that is the result, and from that result you are getting a confusion matrix, and from confusion matrix you can just like predict the things. So this is just like for understanding, I'm just creating a very simple example. Just like for understanding, this one is a fire alarm. So fire alarm is a just like you want to say that when it will be just like giving you. So on the actual data, so this is your actual data. So I'm taking actual here, these are the alarm yes and alarm no, and these are the predicted data, that is predicted fire yes and predicted fire no. So these are the things. So when you are getting just like actual is also yes and predicted is also yes, then it is known as true positive case, because both are yes. When actual is yes and your predicted is no, then it is known as false positive. When actual is also yes and the predicted is actual is no and predicted is yes, in that case that is known as false negative. And when your actual data is you can say no and your predicted is also no, then it is known as true negative. So this is known as the confusion matrix, and by the table command you can directly build the confusion matrix in R language. By single line command you can create this one, and you can find out the accuracy level on the next row. That is the case. So just like you can understand that how we can interpreting this confusion matrix like that. What is the meaning of true positive? True positive means the alarm goes on in case of fire. So this is the fire case. So definitely when fire is there, the alarm will be just like it is goes on. That is the case, that is known as true positive. When we can say a false positive, false positive means when alarm goes because actually alarm is there but there is no fire also. So might be possible that there is no fire but it alarm is going, then it is a case of false positive. Like that in the third case, it is a there is no alarm while your case is of fire. So that is the case of false negative, you can say. And last one is there is no alarm and there is no fire also. So this is the last case is known as true negative. So this way you can just like understand that how we are interpreting a confusion matrix. Let's try to do it. I'm giving you a very simple example. So in the next 5-10 minutes we can just build a model in R language. So if you are having installing this R is perfectly fine, no issue on that one. Otherwise what I'm doing is I'm taking this as an example. I'm having a telecom industry data with me. So just I'm opening that one. So this is my telecom data in which there are a lot of rows and lot of variables are there. So there might be a 20 more than 20 variables are there, and there is a churning, that is the key variable. Churn, the meaning of churn is that the people are in your company or they are leaving with your company, means they are taking your they are taking the services from your company, or they are not taking the services from your company, means they are leaving your company and joining to the other vendor. Like that is the case. So that way the telecom industry having a take care for this one, and they want to find out that how we can go ahead with this one. So for that we want to make a tree model for this one, and the basis of that we can just like building a matrix on the basis of that one, and then we can go ahead with this one. So just like For that you have to keep in mind, you have to just like set your working directory. There is a command that you can, if you are writing here get wd, so it is showing you what is your working directory. Right now I'm taking f column webinar. Otherwise you have to use the command for that one, is that is your set wd, and then you have to put your whatever user working directory is there. So you can just like putting like that kind of things. Here is the webinar, so just like you can use this set wd and your working directory will be set to webinar. So this is my working directory. After that I have to use my read.csv command for that one. That is, I'm reading my csv file, and that I have to put in the ports and my data, just like it is putting in this webinar directory, and this is my telecom data. So I'm using this telecom data as a my key data for this one to keeping in this R. So I can write here my telecom data dot csv, that is the extension of that, that is my data. And this I can just like define to a variable, that is for example that is a data frame for variable, so I'm taking as a df1. So this the meaning of this one, whatever the data which is available in this telecom data, this will be directly coming to my R studio, and it will be, I am just like giving this as a variable, that is a df1, so it will be coming to the df1. So if I'm writing here just like for example view df1, so you are getting a complete clear cut picture, that like that you having a complete, just like see here 7043 entries are there and 21 total columns are there. It is just showing you on the top of the screen. So the meaning of that, it is having a data row for 7000, more than 7000, it is actually 7043, and you have a total 21 columns still from start to end. That is the case. So the your next question is that how you are building a model, that is a tree model, on the basis of this one. So for that there is a two thing, very important thing. Number one thing, that you have to use a package ggplot2, that you have to install it, so that you can install from this package, and you go to the install, and then here you can just like put ggplot2. So you are getting the ggplot2, and you have to install this one. And I have to, after that you have to use the library ggplot2. This is first step. The second step, that you have to use the package, that is the ca tools. So ca tools, this is the package ca tools, and this you have to install, and then you used to use the library ca tools. This is the two basic steps. ggplot2 is basically a library for just like a grammar of graphics, you can say. It is an inbuilt library where you can have a different kind of the visualization. So that's why you have to use ggplot2. And the ca tools you have to use, just like you want to split your tree, on the basis of that tree dot split, you want to use the command. If you are not using the ca tools, you cannot go just like tree dot split command. Just see here, if I'm writing here, because I'm using already this one, so just like I can write a library, for example library ca tools. So this will be automatically coming when my package is installed. After that you can use this library, and when you write this tree dot split, so you can have it just like tree dot split command in this one also. So like that we can create that kind of the library tree you have to use also. There is another library, that is a tree, so you have to use the tree library also. And after that, now we want to build a model kind of thing. So how you are creating a model, that is important thing. Just like that, for that you have to take a data, and that data will be your, you have to create a test data also, and you have to create a training data also. That is the case. So for that, what you do, you have to split that one. So for that you have to command is sample dot split. So this sample dot split is also coming when you are just like using this ca tools library. So that is the command for that one, sample dot split. And what is your data? So that is your df1, because we are already assigning this to the df1. And here you put the variable, that is on the basis of churn you want to find out. So we can take just like put the dollar symbol, and you are getting a complete all the variable. Just I'm putting c here, so I'm getting churn here. So df1 dollar churn. And then here I have to use the split ratio also. So I have to use split. Directly you are getting the command, so no need to remember this one, it will automatically came. This is the syntax for this. And then you have to write 0 point, for example 65 35% I have taken. So this is my threshold value, you can say. I'm assuming on the basis of 65 35. So I'm splitting my this as a this one, and this I am assigning to a variable. And say for example I'm giving this as a variable, my, for example I'm giving as a tag 1. So this is my variable for this. So the meaning of this one, you are just like splitting this data on the basis of 65 35. So you are splitting the whole data set into the 65 35, and this will be gone to the tag 1. And then after that you want to create a train model, and then you just like train data set also and the test data set also. So train data is your 65%, basically that is true. So it is converting your data on the basis of 65% data is true, and the 35% data is treated as a false, like that case you can understand. So this way, what you have to do, you have to use the subset of this one. So that is the subset on the basis of your data frame, that is your df1, and then you have to use your split tag. So your variable is tag 1. So here we can write here tag 1. So automatically it will be converting to the object. So you can take the tag 1, and that is equal to true. So this data is known as the train data. This I can say it is my train data. And the similar case, I can have a subset of my df1 where my tag 1 is equal to false. Then this data is known as my test data. So just like I'm just like splitting my data to train and test, that is my 65% data and 35% data. So this is the case where, so just like if you are writing here, for example, if I'm writing here, for example, view, for example, if I'm writing test, what you are getting, just see, you are getting just like 2465 entries from this. Previously it is 7000. Now this test data, because it is splitting on the random basis, so it is taking 35% data and it is converting to this. Just like if I'm writing here view train, so you are getting a 65% data, which is 4 5 7 8 entries are there. And in your actual data, that is your view d1, that is the complete data of your all the data which is available in your view. So just like we are splitting on the basis of this train, and on the basis of just like creating a subset from this by splitting tag 1 is equal to true and tag 1 is equal to false, we are splitting our data to the 65% and the 35%. And 65% we are treating as a train data, and 35% we are treating as a test data. So this is the case where we are just like splitting our data set. And after that we want to build a model on the basis of this one. So for that we want to create a tree model. So just I'm using very simple example for this one. I am taking just like the question is just like on the basis of churn, that is the main field, and the tenor is my second field, which is this one. So on the basis of that I'm creating a tree model. So here I have to put the command churn, take the that variable, that is churn, and then use the tilt command for that one. And then you have to use next one is tenor. So use tenor, this is tenor. So just go with the spelling TENURE, and it is in lower. So suppose some variable is capital, so you have to take capital here because it is a case sensitive language, that is the case. So this is the tree model we are creating on the basis of this. And in this syntax you have to write a data is equal to what you want. So that is your train data. So you have to write here data is equal to train. So this way you are creating your model on the basis of this one, where you are just like doing that kind of the stuff, where you are creating your model in a new model, and you are creating data is equal to trend. And this you can say this is my, say for example, it is my model 1, for example. So this model 1 is created, and this on the basis of this model, if you are just like writing this, like I want to plot this one, for example. So if I'm using the plot command for this one, and if I'm writing model 1, so if I'm giving this model 1 here, so it will be plotting for you, and it is giving you just like a tree kind of the structure, like this way it is showing you. There is nothing in this, but it is showing you like this way. Okay, so for that, what is inside it, you can just like put text here, and then text on the model 1. So it will be just like showing you text on the basis of tenor we are getting. So you are getting this kind of the things when tenor is less than 16 fine, you have a no, and then there will be another case, there will be a tenor on the basis of less 58.5. So you don't worry about that how this is going to be doing this kind of the thing, and it is creating this kind of the tree. So reason is that whatever the logic band, the Gini index which I am explaining you, it is already taking care for that in the functions. And when you are building a model, it will be already taking care from that one, and it will be already will be creating a tree like that. Like that simple case, what we do is in the just like let's create on the basis of the other thing also. So let's say tree, just like we can take example. Hello guys, yeah. So might be there is a problem with connection, so it will be just I'm reconnecting it. So I'm creating this model. Here I'm just putting this trainer with monthly charges, and this the spell is a typo mistake there is, so I'm getting error. So just I correct this to the monthly charges, and this is my second model I'm creating. And after that, if I'm plotting the second model, so if I'm writing plot and model 2, so this will be, you are getting this kind of the structure right now. See here, so this is the tree. On the basis of it is just like we are taking the two variables, that is tenor and the monthly charges. So when you text it, so just type here text, and after text you have to write model 2. So it will be like tenor and monthly charges. So tenor is this one, then after that monthly charges, and you are getting this kind of the structure. So this, you are creating your model on the basis of this one. Next step, that you want to predict something from this model. So from that you have to be a use a command predict. So there is a command that is a predict, and from predict, from where you want to put, suppose from model 2 you want to predict. So here you have to write your model name, so that is your model 2. On the basis of model 2 you want to prove, and then you have to write a new data is equal to on the basis of your test data. And here you have to write one another syntax, that is known as type is equal to, you have to write here class, that is a classification kind of the model. So this is my prediction, and then this I assign to, for example, I can assign this as the result 2 because it is a model 2, so I am giving it as the result 2. And suppose if I want to predict from the model 1, so nothing else I have to give here, I have to give the 1 only, and just I can change this variable to 1. So this is the my prediction from model number 1. So that is the case. So you are having a prediction also. So this is your predicted data, you can say. And from that you want to build a confusion matrix which you understand. So how you can build the confusion matrix? So you have to put the table, that is the table command, and on the basis of your actual data. So what is your actual data in this one? So that is your test data, and the test data you are taking the field is churn from that one. So you can take the churn, and this is the result 2 is your actual. So that is you have to take the result 2. So this will be a complete confusion matrix you are creating on the basis of no and yes, like that you are having a no, this one, yes, this is the confusion matrix. And if you want to find out the accuracy of the model, then you have to take 1669, that is your total no and total yes, you can say 1669 and 250 divided by the total of all. So that is the total of all means it is 1669 plus 142 plus 404 and then plus 250. So this way you can get a accuracy of your model. So you are getting that 77.84. So it is coming 0.7784 means 77.84% is the accuracy of the model which you are creating on the basis of tree model. So this is the case where you will understand that how to create a tree model by creating a simple syntax in R. So to learning the R is very easy to you. Number one thing is very easy to understand, and anybody can learn, whether it is from the any background. Whether it is not necessary that you have to be a from programming background. You might be from the data background, data science background, data background, or a database background, or you might be a programming background, or you are not having a programming background, or you have a statistical kind of the program, like any kind of the background. So anybody can learn this data science in very easy way. Lot of scopes are there, lot of things are there where you can learn. So a lot of tools are available in the market that you have to learn a lot in data science as far as data science is concerned. So thank you guys, thank you once again.